Hi everyone, welcome back. Today I would like to shift gears and move into programming Java using the Greenfoot program. So let's download Greenfoot together. So I've just typed it into this Google search bar. As you can see, it's a big Greenfoot. That's what we're looking for. And Greenfoot is made by the same company that makes BlueJ, King's College London. And I love this software again because it's got all of the Java programming stuff built into the actual software. So you just click on software, please, and pick the one that matches your system. Most likely one of these two, unless you're using Ubuntu. You can download the pure Java version, but you have to have the Java JDK installed. This is a neat idea here. It's run standalone on a thumb drive, and it's pretty cool because then you can take it to other computers and show off your stuff. One of the things I love about Greenfoot, though, is making an account. And I have an account, and once you make an account, you can share your designs, but you can also search and find other people's scenarios that they have made. That's what a Greenfoot program is called. And you can see some of them are pretty elaborate. Others are fairly simple. I'll search for maybe for myself. Let's see if I come up. Well, that just makes sense. Let's do, maybe it'll be under J. Wilshire. Aha, look. There I am as a member. You can see J. Wilshire. I do have some scenarios. These are a couple of like advanced algorithms, but then I have a Space Invaders. One of the things that I like about this is that it's able to have a high score. And so after you're done playing, you can, I really don't even know how I made this, to tell you the truth. Oh, it's, okay, A and D. Maybe I should have read the instructions. Anyway, so it allows you to play it online. It runs a little smoother when you download the scenario. Anyway, so feel free to check that out. Again, Jay Wilshire, and then you can check out my other scenarios if you want. Okay, well, after you've got Greenfoot downloaded and installed, you should be able to open it up, and it looks something like this. Now, Greenfoot programs are called scenarios, so we'll need to choose a new Java scenario. And the scenario that I would like to start with is, let's try, I want to call this one, I think, call it Lemurs, because I'm going to be doing some lemur stuff. Okay? All right. So you'll notice it says the world is being constructed. And we have over here, this is our classes. And this here is our program. So if you double click on my world, you see it's got some code already made. And they're suggesting some Java documentation. So the first thing we're going to do is we're going to take out your name and we're going to put your name. And this is version 1.0. You'll notice there's an import statement. So there, java.lang is automatically imported for us. That allows us to do system.out.println, make some integers, strings, things like that. Those are all the absolute bare necessities to do anything in Java. But most advanced type of program is going to have to import something. So we're importing the entire Greenfoot package here. And all the my world does is called a constructor in the super class with 600, 400, and 1. And they actually have a comment here that explains what that is. I'll let you read it. But let's open up the world. Now, the world class is already written for us. And we are not able to edit it, but we can read the documentation. So the documentation is what is the public aspect of it. So it says world is a world that the actors live in. It's a two-dimensional grid of cells. So this is going to be for making two-dimensional projects. So we have a couple different constructors. We have the one that we are using right now. World comes with world width, world height, and cell size. I can click on the constructor, get some more details. So the world width is the width of the world in cells, the height of the world in cells, and the size of a cell in pixels. So the world that they've created for me is 600 by 400, each being 1 pixel. And so that's what we have right here. You'll notice that we have methods available to decorate this, but let's just leave it that way for now. All right, the next thing I'm going to do is I'm going to open up the actor class. The actor class is what allows us to put actors onto our Greenfoot scenario. And again, it's a class that we get to use, but we don't get to write in. So what we're going to do is we're going to right click on actor, and you'll notice that our option is new subclass. We can also click off and just make a blank class or even import a class. But I'm going to right click on actor and select new subclass. Now it's going to bring up some helper options, and this is just going to help make my code for me, just a little bit of my code. So the name of this class is going to be Lemur, and I'm going to go to animals, and I get to pick an animal to be represented. You are by no means limited to just these images, because you can create new images, you can paste images, you can import images from libraries. I drew most of the images that you probably saw in that game from Piskel, and I have a Piskel account that allows me to make icons and cool little like 8-bit looking graphics. So I'm going to choose the Lemur option. And so I now have a Lemur class. And you'll notice that it's populated some with me. I'm the author of this class. And this is, of course, version 1.0 as well. So they've got some pre-made code for us. First of all, it says public class Lemur extends actor. Well, we knew that was going to happen. That's what that arrow means. We selected that to happen. So extends, remember, is what makes this a subclass. And we've got some Java docked here. It says act, do whatever the Lemur wants to do. This method is called whenever the act or run button gets pressed in the environment. All right, you might notice that these curly braces are kind of in line here. I like to have them, at the end of the line. And so I might fix that. I might just leave them that way and, continue on as that. So let's put some action in here. So what do we get to do? What can we make our Lemur do? Well, that's where we go to the actor class and pull it up. I already had it up. I just want to show you how to do that, though. So I've got them switched between, and I've got my class, and I've got all my different choices to choose from. You'll notice that there is an act method already there. So if I click on it, it says the act method is called by the Greenfoot framework. Let me enlarge this a little bit here. To give actors a chance to perform some action. At each action step in the environment, each object's act method is invoked in an unspecified order. The default implementation does nothing. So, in fact, the default implementation is this right here, empty. See, it's void, so it doesn't have to return anything, right? So we want to improve on that. We want to override the act method from actor, which is okay because we get to inherit all these other code that is not absolutely nothing. There's lots of things that we can do here. All right, so you'll notice that as we read the documentation, we have a modifier and type on the left. So if there's no modifier, we know that means it's public. So you will notice that there are some modifiers here called protected. And so Greenfoot will allow us to call certain methods only in a subclass. So they didn't make them completely private methods, but they made sure that I can only call it in a subclass. So, for example, I can call get intersecting objects in the Lemur class because I'm a subclass of actor. That's what protected means, but I can't call it from the world class. And they do that to kind of basically to help us, to prevent us from making some mistakes that could cause some big runtime errors. All right. But basically, most of these things here are public, and we'll get to this protected one later. But for now, I just want to do something simple. I want to do move. So you see, I've got this method move. It takes an int distance. We probably don't even need to click on it to guess what it's going to do. So move this actor, the specified distance. Distance, the parameter is in cell size units. So my Lemur could move 600 cells because that's how wide my class is. So let's go ahead and do that. Let's say move and I'm going to do 20 just so we get a feel for it. We'll compile it. And to make this happen, we gotta instantiate this class. So I'm just going to instantiate Lemur. I can't instantiate Actor because it's an abstract class. Abstract classes can't be instantiated. But I can instantiate Lemur. Here's a new Lemur. And I'm just going to put him here. And if I press the act button, it's going to call the act method one time. If I press run, it's going to do it over and over again as affected by the speed of the program. And we can set the speed in the world class, but we can also just adjust it here on our little workbench. I'm just clicking act over and over again. And I can actually click and drag him over. So that's pretty fast, right? But 20 pixels is a pretty good long way to jump. I wouldn't call that very smooth. I'm going to change this back to 2. And we're going to try that again. Okay, I got to remake a Lemur until we code that in permanently, which we'll show you how to do that later. And that's a little bit smoother animation, you know. There is some jostling when it first starts running. And there's ways to make Greenfoot run smoother, but I just don't want to get into that. But there we go. All right, that's not bad. So you'll notice it runs until it reaches the bounds of the world and stops. That can be controlled with the constructor in world. So we have 2 constructors. The default one will automatically make the world bounded. If you call this one, you can actually give it a false, whether should actors be restricted to the world boundary, so that we could have actors run off the screen and control them in a location that way and then bring them back in at times. But that can be more code heavy on you, so it just depends on what you want to do for the scenario you're doing. All right, so I've got a Lemur and he runs seeing the screen, but you know what? I think we can do better than that. Let's make the Lemur turn. So I'm going to make the Lemur turn an amount of degrees, but I want to wait and turn until I get at the end of the screen. So I'm going to look through here and I'm going to find something that determines that. And you'll notice it says it is at edge. Detect whether the actor has reached the edge of the world. So it's a method. All right. So this method belongs to the superclass of Lemur. So I call it just like I would if it was written in the class I'm in. I don't have to get an object and then put the dot operator on it. I just call the method as is. So I say if, I've already forgotten the name. Is at edge? Is at edge. There it is. If is at edge. And I love the way it's so easy to read, right? It just reads like what you're saying. If you are at the edge. If is at edge. What do we want to do? We want to turn 90 degrees. All right, now this isn't going to quite work, and I'll show you why, but I wanted to start with it. All right, let me make a Lemur. And I want to make him run. And now we should turn, but you'll notice he flips upside down. And the reason why is what happens is he's on edge, and he turns 90 degrees. And then starts running up this side, but that's on edge as well, so it turns 90 more degrees until it finally moves out. So what I'm going to do if I'm on the edge is I'm actually going to move -2 to undo the move I just did. And that's just going to make things a little bit cleaner for me. All right. Now I can control the direction that the Lemur rotates, of course, by using positive or negative on the turn amounts. And here we have it. All right. Now let's make our Lemur do something else. I want to have my Lemur go to a specific location. So I'm going to have my Lemur, I'm going to set rotation, I'm going to turn towards a specific point. So let's try that. So instead, I'm going to say turn towards. And I'm going to do 0, 100. Let's see what happens. There's 0, 100 right there. And now he's just continuing to turn back and forth times 0, 100. All right, let's try another one. Let's say I want my lemur to go towards, let's see here, I'm 300, and then what are we, 300 by, we were 300 by 400, right? Okay, so I'm going to make him go straight to the middle after he hits the wall. So I'll make a new lemur, but I'm going to put him there. And so 300 by 200 should be about right here. So remember, the upper left-hand corner is 0, 0 with these coordinates. So this is 0, 0, and then this is increasing x to the right. This is increasing y going down, a little different than math class. So this over here is 600, 400. So that's pretty neat, right? Let's play around with that a little bit more. If I can actually get the x value as well of my lemur's location, and I can give it specific places to go. So I can say, let's do the get x. All right, I'm actually gonna just do this instead. If get x is less than 300, then I am going to face to the right. So how can we make sure that we face to the right? Let's take a look and find that. Well, we can set our rotation where 0 is to the east, right-hand side of the world, and the angle increases clockwise. So 90 is straight down, which is, again, kind of backwards in math class, but it makes sense if you think about the way that their y's go down. So that's the way it's going to be. So I'm going to say set rotation towards 0. Then I'm going to say else if get x is greater than or equal to 300, I'm going to set rotation towards 270. Okay. All right. So he's going to go. The lemur's going to move until we get to the middle. Then we're going to go straight up once we get to the middle. Uh-oh. I forgot to tell him to move. All right, so I will put that here, down at the bottom. We'll say move 1. All right, let's try that. All right, there he goes. There goes the lemur. And there he turned. All right, so what we're going to do for this first assignment is I'm just going to have you play around with moving and turning. And I want you to make a program that has a Greenfoot scenario that makes your animal move around and wander around the world, and just practice calling the methods from the actor class. So I'm looking forward to sharing more of this with you. And until I see you again, take care.